Hello everyone, we have aimed to create a ZK auction which takes the bid, nonce and commitment as the input through a circum circuit and checks whether the expected commitment matches with that of the original one. Now for the calculations of the expected commitment and matching it with the original one, we have made use of a Poseidon circuit, and for the verification part we have used a ZK verify. It utilizes a Groth 16 palette with that of the BN curve type of the 128. Now, if a user wants to create an NFT using that of our platform, he will be just set to that of the create option and will choose a file to be that of its image. And he will list a price, an auction duration, and the reveal duration. Now, the auction duration is something that will be added with that of the creation time, and the reveal duration is something that will be added in addition to that of the auction duration. Now, after it gets being created, it will be listed in that inside that of the auction page. This here. So after that, it gets entered in that of the bit phase, and the bit phase exactly ends in 852. Now I will head back and I will create and I will calculate my uh, commitment based on my bid and nonce. For the bid and nonce, I have picked 0 and 6, and the commitment comes out to be that of a big number. Now, I generally not recommend using this kind of the randomness, and the randomness would be likely if you use a greater number, say a Mercedes prime or something, that will result in a commitment to be more of the secure. I will provide the commitment back inside that of the app, which will be get saved in the contract in form of that of the expected commitment. And after it gets saved in the contract of the expected commitment, when the reveal phase will come and a user will provide his bid and nonce, it will be calculated whether the expected commitment matches with that of the computed bid and nonce utilizing that of the ZK verify. Now this phase will continue for a while and it will end since that of the 852. Now while it takes place, I will show you how that the previous interaction which has takes place inside that of the app, where we have find it to be that of the ZK utilizing the ZK verify, that when provided the correct bit nonce and expected commitment fetch from the NFT auction contract, then it comes out to be that of the true, and it shows that the app contract has acknowledged that one can verify. Now, the time is exactly 8:51, and these are the few of the contracts that we have previously created, and it is listed here as shown. And if I head back to a different kind of the address, say 0181, and it will be should be given with that of the opportunity of that of the investing and buying this kind of the contracts. And the commit phase has ended, and we are now in reveal phase. So I will go and provide the reveal amount. Refresh it once. Yeah, and I will be providing the bid and the nonce. That should be, if you have remembered, is 0 and 6. And after I click the reveal bid, if we will be directed to that of our app.js, which will be starting to work. And as you have seen in the exactly 8:52 and 29 seconds, and it is checking with and passing our transaction to that of the ZK verify node. Now we have making use of the ZK verify events to check whether our transactions have been to calculate and to see the state of the transaction in every point of time. Now you can see transaction accepted, finalized. A few more seconds to go before we see our proof coming to life. And if keeping in mind the pros and cons of the using the particular module, the circuit, if one's written the circuit in a particular language, say for circom or in rust or any other language, and once the interaction has been cracked till the entire event is as smooth as working on that of a piece of a cake. The transaction has been finalized. We have previously registered the verification key hash using that of the ZK verify and the subvalid extension. And the Merkle proof details have also been shown. A few more seconds before the the entire thing gets sent to that of the app contract, and the app contract acknowledges that whether we can verify it correctly or not, keeping in mind the expected proof matches with that of the computed one. When the transaction has been sent to EVA, the transaction hash is acknowledged, and voila, we can see the app contract shown. A few more things I will show you. That is the exact thing in that of the RB scan, the transaction hash, and it's just here. It has arrived, and I will also show you the transaction hash for the transaction being accepted in that of the ZK Verify Explorer. Just a second. I will try with some previous one. Maybe this one haven't been logged by this time. Right. There might be some problem happening with that of the ZK Verify. I will check it once again in a different tab. And it's here. So that's all will be from my side. Thank you.